So now we're gonna. So so because of the way the labs work this semester, I needed to bring the. I had to do the file reading yesterday or on Tuesday. Normally, I don't do the file reading example until next week because because that's when we're really tackling and getting into the file reading. But because of the way the labs are scheduled, I think last semester they were scheduled to be on Fridays and Monday, which meant as a result that the lectures were before the labs, so that made sense to do it that way. But because of the way the lectures are spread out basically every day throughout the week, I wanted to do it now. So we're going to backtrack now to do those loop exercises, that PDF that was previously like had a due date of the 13th. So we're going to do that in class exercise today. The other thing, but before we do that, I want to talk about the exam and the grading process first, because I've gotten a lot of questions about it, and I haven't really responded to any emails because I wanted to address that here. With regards to the grading, the way it works is I have the TAs make the primary pass over it. Now, if you remember, the TAs are graduate students, and for the vast majority of them, this is their first time as graduate students, meaning that this is also their first time being TAs, meaning it's their first time grading an exam. And I told them also with regards to the exam, in terms of in grading, to be harsher when in question than being more compassionate. Well, now why is this? Because it's easier for me to give you points back on the second pass, or if I review your exam, it's easier for me to give you points back that you should have earned, rather than take away points that you should not have earned. Make sense? So if you feel like you should have gotten more credit for it, there's a few examples where I feel, yes, you should have gotten half credit for it rather than zero. I've already seen that like that in a couple cases. So if you feel like, okay, yeah, but I feel like the answer wasn't so bad, or there were only a few syntactical issues, I'll be happy to take a look at the exam. I just need to just email me about specific problems on the exam, and I will take a look at them. I've just been busy. Also, if you have if you turned it in on paper, I haven't had the chance to look at your paper exams yet, so I will be implementing those paper exams. I'm going to be basically working all of tomorrow on this because the midterm reports are because the undergraduate reports are due Monday, I believe. For those of you who aren't aware, there's undergraduate midterm reports. They serve no transcript purpose whatsoever. In other words, getting a pass or a fail on your midterm report doesn't actually matter. It's entirely set up as an early alert system so that any student who is at risk of falling behind gets a kind of nudge that, hey, you maybe should address this. As a result, I also happen to, because it has no impact on your final grade whatsoever, I do tend to be very aggressive with handing out those notifications. So if you're behind on turning in or demoing your assignments, or you score below a certain threshold, typically 70 on the exam, I generally say that you need to meet to make sure that we can do that. But again, I have to go through if you have issues with the exam, please let me know, and I will look at those individual exams. Okay, and those individual problems on your exam. With regards to how many exams do we have this semester? I'm doing 2. I've done 3 in the past plus the final, which for a grand total of 4. This semester I'm doing 2 midterms plus a final exam for a grand total of 3 exams, because I found that doing 4 it's a bit much in terms of both grading them and in terms of just doing a lot, especially since there's no good place to put the third exam. So the third exam will most likely be week 11 or 12, depending on how that works out. So this is week 7, right? So that's going to be fairly far away. The big difference is that, I also understand that the format of the exam was kind of very different for a lot of you. This is to be expected, but also unavoidable. The reason that the exam was done the way it was is because if I let you use idle, if I did it on paper, it takes forever. If it's idle it takes forever to grade and get back to you. If it's on idle, if I allow you to use idle, then there's two things that happen. First, it takes you forever to complete the exam because you run into syntax errors. And those syntax errors just make a huge issue, just prove to be a huge issue, a huge stumbling point. As far as being able to answer the questions, you might get stuck on a simple syntax error for like 5 to 10 minutes. Whereas if you're doing it on like in a blank screen, you might make a syntax error and we can move on and get to the rest of the problem, right? Now your next exam will have questions that resemble what we're going to see today in the exercises with a few key differences. The ones we do today are fairly basic. The ones we'll do on the actual exam will be a bit harder, but again, I will give you a practice exam. And the exam itself will come with a rubric for each of the questions. So typically I ask maybe somewhere between 5 and 7 questions on the second exam. And each of those questions has a rubric that you can see, saying 5 points for doing this. So something that might be an example that I kind of came up with today of an example question would be like, here's a list, count how many items in this list are greater than 10. So that might be a 15-point question, and the rubric might say 5 points for correctly iterating over the list, 5 points for detecting whether each item is greater than for detecting each item that is greater than 10, and then 5 points for doing a running sum, keeping track of how many items are greater than 10 and returning that answer, right? So I break it down kind of into those discrete steps also to kind of walk you through how to do the problem. So it also means that if you completely just kind of freeze on doing one part, at least you can maybe get points by doing the other part correctly, right? There's definitely going to be a kind of question that takes in a file of like that. Basically, you want to read a file. One of the questions I've used during COVID and was here's a file which has the high and low temperatures for each day, right? So it's column 1 is the day, column 2 is the high temperature, column 0 is the day, column 1 is the high temperature, column 2 is the low temperature. Find the day with the highest, right? Find the day with the highest high, find the day with the lowest low, and figure it out, and then maybe figure out what the average high temperature is. So those were some questions I asked with regards to the file parsing, right? So reading a file and figuring out, based on the data, what goes on there. Now for the future exams, including the final, it's going to be a lot more unrestricted, okay? For that one, for the final exam, I basically let you use basically almost every resource you can. The only the conditions on the second exam and the final are you cannot use. Let's go ahead and see if I can't pull that up. Actually, I have. I think it'll be there on that. Let's see. Yeah, that's solos just simply because of. It'll say solo because that was because I tried a experimental thing of doing it as a group exam last time around, or trying part of it as a group exam last time around. So instructions, So let's see. Oh, I didn't add instructions there. So let's go ahead and figure that out. So what I've done in the past in terms of with regards to instructions are, let's see. Final exam. Let's see with the final exam. I'm sure I've had instructions on there. Yep. Exam is open book, open internet, computer, etc. with the following caveats. You can complete the exam on your own devices and lab computers. This clause won't be there where you'll be able to use your computer, your idle and code for all of the questions, okay? But you can use any coding environment you want to do your programming in, idle, IntelliJ, Eclipse, NetBeans, PyCharm, Atom, VS Code, Vim, I do not care. If it's not listed, but it does what you need it to do, awesome, okay? The exam is open note. Your notes can be on paper. It can be any amount of paper in any form, including the textbook online, so you don't have to worry about printing out stuff this time around. And it can also be notes and code that's stored on your computer or personal cloud, OneDrive, etc. Students can use any access on the internet that is linked to from my Canvas page, such as the YouTube lecture videos or lecture recordings or my GitHub repository. You may not use resources on the internet that are not on your personal cloud, nor that are not leaked to on Canvas. So basically, if you can get to it from Canvas, awesome. Basically, that's a very long-winded and specific way of saying don't try to Google the answers on Stack Overflow, okay? That's basically what it comes down to, but if I just simply say don't put it on Stack Overflow, somebody might say, well, I didn't go there, I went to Chegg, which is like, you do realize that's worse, right? So, anyway, so in other words, it's going to be a lot like, from now on, it's going to be a lot like doing programming for your assignments. Now again, we've got these less comfortable, more comfortable assignments that are due the 13th. If you're having trouble with them, please reach out to your TA or reach out to a classmate or reach out to me to solve these. Okay. But for right now, we're going to, again, back up and do these loop and function exercises. Okay. Okay, so no need to demo them, and then we did this in class. We check these for completion, not for correctness. Done in class this date. That way, we've got this. Save. And again, if it's under the, I've categorized these assignments pretty well. All right. Oh, that was silly. Why didn't I just hit back up? Okay. So so we've got 4 questions that I'm going to take today. Okay? So this exercise serves a few purposes. First off, we're going to get some more practice on for loops, right? Which hopefully you've got a very good grasp of now, but if not, this is good practice for that. Second, we're going to be focusing on writing functions today. And the third is that we are going to be returning stuff today. That's the big focus for today, returning. Okay? Now, the importance of returning as opposed to printing is that if you return something from a function, that means you can give that information to another function or another part of your code to use that later. So here we've got 4 questions. The number of vowels, the number of even digits, 3-digit Armstrong numbers, and which all return something. And then we've got this riddler. If we still have time left over, I've got other questions to do. But these are all kind of very good questions I found for getting some practice done. And again, some of these are easier questions, but they kind of would act as the building blocks for what you would see on exam 2. So, number of vowels. Write a function given a string that returns the total number of vowels that were in the string. So that means you need to feed the function you write a string as a parameter, and you give me back an integer. Okay. So, and again, we don't really need to use input here. Input was basically what we were doing if we want to do input, we do that at the end to add interactivity to our program. Here, for the purpose of testing, we just really want the define function and then give it a string. And again, we want to return our answer. We don't want to necessarily print it out inside the function. Outside the function, sure, but inside the function, not really. So, all right. Let's go ahead and get started. I'll give you the stub for it, right? Okay. Which means, so here we go. Save. Desktop. 10, 12. Okay. 1012.py. Okay. I didn't put a slash in there, so. All right. Next, what we do is def. I'm going to call this function numVals. I mean, number of vowels is a bit wordy and a bit much, but calling it numVals gets across the same less keystrokes gets across the same idea. Num vowels, colon, and then we're going to want, and then we need to put stuff in here. So the first thing is we need to think about our inputs. This will be taking in some string or some text or something and counting the number of vowels. So we need to provide an argument. So we can call it word, I'll call it text. Now, Python is so other languages like C and Java are what we call strongly typed languages, meaning that you would basically enforce and restrict your types. So in Java, I would say something like this, string text, to enforce that only strings could be passed in here. Python uses something called duck typing, which means that if it looks like a duck, quacks like a duck, and walks like a duck, it's a duck. So in other words, if I can treat it like a string, then it's a string. In other words, it doesn't check what it is until it actually tries to use the type. So this allows it to be very flexible, but also it means that it means that you could pass anything into here, including stuff that's not words. And of course, if you do that, you're just going to probably run into an error. Okay, the next thing is we need to return, is that I always like to, especially when, for beginners, I always like to suggest think about your inputs, which we've done, and now your outputs. Our outputs is that we want to count the number of vowels. So I'm going to give it a simple term like count, right? And when we count the number of things, the count always starts at 0, right? And then we're going to do some stuff, right? And then at the end of our code, we need to give that answer back. Return count. Okay? So this, obviously, what we over here in the comment, that's where you're going to put your code, and that's what I'm going to give you a few minutes to do. But over here, but generally speaking, when you're kind of lost at where to start, think about your inputs and your outputs for the function. I'll generally on exams give you this part and tell you what to return. I won't give it you, but I'll tell you, right? So over here, what we want is, again, so what should I do? How do I approach this? Well, first off, with these, we don't really, in this class, we don't really, we always assume good behavior on the user side unless otherwise specified. And I'll plan on going over that today because that's something that a lot of people are struggling with, right? So let me put that in the notes over here. So because some people are struggling with that with the cash and credit program. So we always assume good behavior from the user in this class unless we're otherwise specified. So here we're given some text. What does that mean? We should loop over the text for each character in the text, check to see if it's a vowel. If it is a vowel, increment our count. There's no otherwise or else. Just if it's a vowel, increment the count. Then we can find, now how would we go about printing our answer? We would print out, we would get maybe answer is equal to num vowels, or num vowel. Yeah, let's pluralize it, num vowels. Num vowels. And then this is an example sentence. Doesn't matter. English is. All right. So now we run it, and it's going to tell me nothing because I didn't print out the answer. That's a common mistake I always make, and you will continually make. So when you encounter that and you say, "Why isn't this printing out anything?" Ask yourself, "Did I actually print out something?" Okay, and right now it's printing out count. It's printing out 0 because that's what the value is, and it's not going to change. So now I'm going to give you about 5 minutes. Let's try to work on this one. Now again, there's multiple ways to do this one, so have at it. And one of the things that might help you is some of the strategies we learn when doing the exercise, the leap year exercise, when you have multiple things you're checking. Not the full answer because people are still working on this, but let's go ahead and start putting in our magic. The first thing is, again, we want to do a for loop. Again, what is the strategy for this assignment? We are going to iterate over every piece of this text and and the question we need to ask is this piece of text a val or not? Okay? So how do we go over every piece of text? We need a for loop. So for, and now we can call it, now we need something in letter, basically. Not letter, for something in text. So, right, this is our string here that we're iterating over. So we need to do for in text. And you could call it C for character. I like to say letter, even though technically will be going over spaces, which are not technically letters, but it makes sense syntactically. It makes it easier to read for every letter in the text. Make sense there? And so now that we have this, we need to ask ourselves, is this particular letter a vowel or not? So vowels in the English language are A, E, I, O, and U. There's no sometimes Y. It's just A, E, I, O, U. So keep it simple. Also, for the sake of argument, I'm going to assume that everything's lowercase, so you don't have to do 5. So you only have to worry about 5 letters as opposed to 10, because capital letters are technically different than the lowercase. So 4-letter in text. You need to ask an if statement, right? So that should help you. Now remember how we did the if statement to check if something was one of multiple months in the leap year exercise. There were a couple ways to do that. You had to say if letter is equal to this, or letter is equal to this, or letter is equal to this, or you could say letter in something else. So the excellent news is that for the excellent news for the people who have made minor mistakes is that the mistakes were minor, typically 1 or 2 characters away from the correct answer, or using the wrong keyword, which is, it means your logic is sound, it's just you're still struggling with the syntax. And the logic is really the important part, because because if you are having trouble with the logic, that means that you really need to go back and hammer down on for loops and the if statements and the problems in the textbook. Okay, so here what we're saying is that there's a few ways to do this. If letter is equal to, so here I'm going to do it the long way, but basically the way that takes, I think, the least amount of brain work to figure out. If letter is equal to A, or letter is equal to, or letter double equals E, remember this checks for equality, or letter is double equals I. I'm not even going to bother typing it all out because I think you all get the idea here, right? You do letter equals this or letter equals that. A common mistake is that students will just do this or E or, and list them out like that. If you want to list them out, just wait a second and we'll do that. But at the end of the day, this is fine because you could just simply solve it with a bunch of copy pasting. It's fine. And, you might not have the tools we're going to use in another programming language, so it's good to know how to do it that way. So if it's equal to that letter, in that case we're going to say we found a vowel, which means we should increment our count. So we say count is equal to count plus 1. Alternatively, we could say count plus equals 1. Either are completely correct, both are equally valid. Okay? So another way we could do our if statement is to use the in operator, and there's 2 ways we could do that. The first is going to resemble how we did that in the leap year program. So we would say if letter in, and we'd ask if it's one of these things in a list. If it's an A, I, O, say A, E, I, O, and U, right? If the letter is a member of this list, if it's inside this list, then great. We do the same thing. Count is equal to count plus 1. Okay? Everybody see how this one works? And by the way, it doesn't matter if it's double quoted or single quoted. Python does not care. It makes no distinction between double quotes and single quotes. Whoever wrote Python, the developers of Python determined that was a needlessly complex distinction. The final way to do that, because I want to make sure I'm getting plenty of time for stuff, is that you can, instead of checking if the letter is is a member of a list, you can say if I can find the letter in this string, A-E-I-O-U, if I can find the letter in this string, then it's a vowel, in which case increment. So these are all equally valid ways of, checking if something is a vowel. This is a common checking if something is a vowel is a common operation. I've done it on multiple exams. And specifically multiple exam 2s as part of a building block for future answers. So take that as a hint. Okay. And again, Y isn't a vowel. So here we can run this and we get 9 vowels in this. This is an example sentence, and that seems to line up with what I'd expect. So for our second problem, are there any questions before we move on? All right. This second problem is probably the one that's going to take the most time. My plan is we'll take some time over here. I'll do the 3-digit Armstrong numbers in front instead of letting you do it, and I will plan on going over the is float, and then if we have time left, I'll go over the Riddler exercise. Okay. So now this one has 2 mutually exclusive approaches to getting this. The number of even digits. Write a function which, given an int, returns the number of even digits in the integer. For example, if the function is passed 254, it should return 2 because 254 has 2 even digits. The 2 in the hundreds place is even, and the 4 in the ones place is even. Okay? Now, in this, I said you need to use modulus and division to solve the problem. Now, you're allowed to, for the purpose of this exercise, you can tackle it in both ways. So the first way is to use modulo and division. Now, what do I mean by that? So let me go ahead and finish by writing this up. Def num even digits, and it's going to take in some number, right? Okay, now the key for this is there's 2 ways to go about it. Use a while loop or use a for loop, essentially. The while loop approach is the approach that's kind of more efficient. And what it does is that it relies off of 2 operations, which is that if I've got some big number, let's say like this, num is equal to 2,364,782, whatever, then I can just simply get the last digit of that by moduloing by 10. The last digit mod 10 the number mod 10 always gives me the last digit because when you divide by 10, the ones place is left over. So that's how I can kind of access it individually. The other key operation is that if I take the number and I divide by 10, in other words, do integer division, then I get 236,478. If I divide the number by 10, I essentially toss out the last digit, right? So read the last digit by modulo by doing modulo 10, toss out the last digit by dividing by 10. Excellent kind of operations there. Okay? So, and what I would do is that I would say, while this number is bigger than 0, I'd read the last digit, and to toss away the last digit, to make this number one digit smaller, I would do number is equal to number divide by 10 to toss away the last digit. So see there, I give you number, and then if I do it again, right, if I do it again, I'm continually throwing away the last digit. Now the less efficient way, but possibly more, the less efficient way, and it does take more lines of code too, but possibly easier to kind of come up with way, is to turn this into a string and then go through each digit and then turn each digit back into an integer and then check if that is a even number. Oh, and how do you check if it's an even number, by the way? Yes? Yep, using modulo 2. If the remainder after you divide by 2 is 0, it's even. All right. So let's see. So let's go ahead and do this again. I'll use the same vocabulary. Count is equal to 0. Return count. Right? Right? You put the code there. In between your always do the return at the end, because return kind of stops it kind of ends the function. So again, depending on how you do it, if you want to use the strings, which takes a bit longer, you'll be using a for loop. You'll convert it into a string and use a for loop. You can't do a for loop on an integer. You'd have to convert it to a string first. So the other way, which is the way I plan on doing it, is while num is greater than 0. Okay, and that's what I plan on doing for mine. All right, so take a few minutes to try that. So first off, the one point of concern that I would have is that if you copy this part to try to get things to work, you need to spend the entire weekend probably practicing this course, because that part was not relevant to any of this. So I didn't see any students do that, but that's just kind of that is like one of those red flags right there, that you have difficulty in this class. So now what we can do, so there were a couple ways to do this. Again, one way I saw was this way. The way you would do it with the strings would have been like, four letter in, or let's call it letter in, even though it's not a letter, in string, to convert it to a string, num, right? And you'd iterate over it like this, and then and then you'd convert it back. I'm not going to do that because we're limited for time. So I'm going to instead focus on the way that I want this problem to be done mathematically. Okay? So what we're doing to iterate over this is that we're going to look at the last digit, and after looking at it, we discard it. So at the very end of this while statement, to discard, after we're done looking at a digit, the way I discard that digit is that I cut it off of the original number. That was the num is equal to num divided by 10, right? Now, to get the digit that I want to look at, that was the num mod 10. So that gets me the rightmost digit. So over here, digit is equal to num mod 10. That gets me the rightmost digit of a number. Any number, it's going to be the rightmost digit. Now the question is this a even number or not? Okay? Is this an even number or not? If digit, not dog, digit is even. So how do I check if it's even? I do modular arithmetic again. If digit mod 2 equals 0, right? That's an extremely common one. Why is this so common? Because a lot of times we might use a number and we kind of might flip a switch as we're incrementing that number, right? So it might go from 2 states, an on and off state, and we just simply increment to do that. So if that specific, so we get the last number of this, the last digit of this, the rightmost digit of the number, store it in here, and we ask if we take that number divided by 2 and we get no remainder, that means it's cleanly divided by 2, which means it's even. So that's where we finally put in the line that we need for the answer, which is count plus equals 1. Once we're done looking at the number, regardless of whether it's even or not, that's why it's outside of the if, this part's outside of the if statement. Regardless of whether it was even or not, we then discard the rightmost digit to basically shrink down the number by a power of 10. So here, I will take this, I copy paste it there, and then I can just type in a number. Easy to type that one in. And then we just run that, and that should give me 4 even digits because it's got 2, 4, 6, and 8. The only other one in there would be 0. And now this stops because, now the only one this will be kind of incorrect for is if we pass in 0, it's going to say 0 has has no even digits, which we can fix that in a second. But otherwise, the way this works is that every time we chop off a digit, we're getting closer and closer to 0. So the way this would work is that it would chop off the 9, look at it and say that's not an even number, so don't increment. Oh, that is an even number, so I'm going to increment. 7's not even. 6 is even, so increment. 5 is not even, so 4 is even. 3 isn't. 2 is even, so increment. 1 is not even. So now we would get to this last part. So we would have got it. So we would have stored 1 in here, checked if it was even or not. And now we do num is equal to num divided by 10. 1 divided by 10 is 0, remainder 1. So we store 0 in here. So while the number is greater than 0, 0 is not greater than 0, so we stop. So that's how that works. If we had less than or equal to, it would be a legitimate infinite loop there, because we would never actually get past that point. Now, there are kind of 2 edge cases here that on an exam I would either make you aware of, or I would consider to be extra credit, which is what if it's 0 and what if it's negative. For negative, it really shouldn't matter too much, right? If you think about, except for the fact that if number is divided by 10, except it would never run because the number is going to never be there. So we'll go ahead and write some what we call base cases over here, which are basically easy to answer questions about the answer. So if num equals 0, how many even digits does it have? It has 1 even digit, so I would return 1, right? If it's just straight up equal to 0, and that's what we get passed in, we'd have 1 even digit. 0 is even. Okay? And then finally, the other one is the other base case, which again would be, again, I'd either make you aware of these on the exam, kind of a heads up, or give you, or say these as extra credit. I would do if num is less than 0, in other words, if this would never run because number is negative, well, a negative number and a positive number of the same magnitude, of the same values, they're going to have the same number of even digits. So we just simply make it a positive number. We could do, like, there's a math.abs function, but honestly, why bother? Just num is equal to number times -1, and that switches it to a positive number, right? So now, if I test this on negative this value, I'll get 5. Because it takes the negative 12, 34, 56, 78, 90, converts it into a positive over here. So again, that's just kind of the what ifs there, and I figured I might as well bring them up. Before I continue on to the third and fourth problem, I want to go over the isFloat function. That was something I wanted to do today. That was in the less comfortable for the for cache. So Now, first off, the is float, part of the whole cache problem is to kind of make you understand that when you have a big problem, sometimes the parts of the problem are independent. Solving the problem and checking if your input is valid are two completely independent parts. So you can do one without the other. But checking if something is a float can be very difficult. Checking if a given string is a float, let's take a look at how to do that. Def is float. So the way I would do it is when I've got a discrete task like that, checking if something is a float or not, guess what I'm going to do? I'm going to turn it into a function because that means I can work on it independently of everything else. That's kind of the useful ability of functions, which is that it allows you to organize your code. Yes, you can make one giant long mess, but honestly, that does you no favors. You're a great person. You designed to be. You should. You deserve to be kind to yourself. So do that by making sure you organize your stuff. Okay. So here we're going to basically take in some. Again, it's going to be some text, or some string. Let's see. Can I call it string? Yeah, why not? I'll call it string. So we're given a string. We want to check if this is a float or not. Okay? So, and now, the way I've seen some people do this is a way that basically uses some stuff from the textbook that's later on, which is a try except block. Basically try to convert it into a float. If you can't, then it was not a float. Except that causes an error, so you have to do something called a try except block, which catches an error and basically allows you to recover from an expected error. I don't want to do it like that. Okay? So what are the valid characters in a float? What are the valid characters in a floating point number? Yep. Yep, the numbers in the decimal point. Also, possibly, there's also one other character. The minus sign. But, that technically wouldn't really come up here in our thing, so we'll ignore it for right now. But yes, exactly right. The number's in the decimal sign. So what we're going to do is that we are going to, so with a float, right, we're not caring if it's like an IEEE floating point notation, which means it would have only a certain number of digits. We're just kind of just going to look at it in terms of like an actual floating point number. So an actual floating point number can have as many of those digits, of each of those digits as it wants. Only one period and none of the other characters, right? So what we'll do here is that we're going to use a string and we're going to do a for loop. Very easy, straightforward for loop, which is we're going to say for digit in a string, or maybe we should say maybe for character in string. Sure, why not? For character in the string, a character being an individual bit of text, we should ask ourselves if this is a valid character, one of the ones that you so helpfully mentioned, which is if car in, and again, the in is so much easier to do here, 0 through 9, or the decimal point, right, then that's a valid character. But what I should be doing here is, now we need to stop and think. Does checking if it is a valid character actually do anything for me? In fact, what am I trying to do with this function? I need to, when I write a function like this, I'm trying to return, let's just pause for a second and back up, because sometimes we just go forward and attack the problem without actually thinking. What am I trying to do here? I'm trying to detect whether something is a float or not. If I want to make that useful for another function, it's a true or false question, right? True if it's a float, false if it isn't. Now, in this case, let's just take a moment to think about it. We should probably assume 1 and then try to disprove it. So I think it's easier to assume, and evidence will bear me out, it's much easier to assume that it is a valid float and then show that it's not. So we're going to assume it's a float. So by default, what we're going to do is we're going to just put return true at the bottom. And then as soon as we see it's not a float, we're going to go and return false, right? So like, for instance, if we detect a single character, what would that mean? If we detect a single character that's not valid, we'd return false. So now what we'll do is we'll change this. For every character in the string, if the character is, rather than being in, what are we going to ask? If it's not in, right? Easier to do that than to list every other of the literal millions of characters that exist. Because Python is an awesome programming language and accepts things other than accepts things in UTF-8. So if the character is not one of these, then we can immediately say return false. This is not a floating point number, right? Now you might be thinking, well, wait, does it matter where this period occurs in a floating point number? And the answer is no. For a floating point number, right, these are all valid kind of representations. 0.1, 0.1 is also valid, right? Right? You've seen that written sometimes, although we try to tell you not to do it because it's so easy to kind of miss that. Also, 1 point technically is a thing. Why would you do it that way? I don't know, but it's valid. So the long story short is you don't have to worry, though. That's kind of, I think, the good takeaway. So first off, we check every character, and if it's not one of those, we return false. And that's going to cover most of our cases here. It should be able to be turned into a floating point number at that point. The only exception we might have is if somebody tries to type something like this, point, like that. So we just ask ourselves one more question to check if it's a floating point number. What's the question? If there's what? If there's two or more. Two or more. But yeah. Now, and the reason I say two or more is because we're gonna rather than going through and manually counting, there's two ways to do that. First off, you could go through and manually keep track of the number of periods, but I prefer to do it like this. If string dot count period, that should work. I don't think count takes in a regex. Excuse me 1 second. Now I have to check if things are going to go horribly wrong. Give me a second. String count Python. Okay. Why does it not give me the official documentation? Common string operators. This is what I want. Count. Okay. No, really? You're not going to give me that? Okay, you're doing the string count substitute number of substring. Okay, great. So it is not a regular expression. If you wonder what that is, don't worry. That's going to come basically after I introduce the final project. Regular expressions is one of those things I introduce in class because there's literally no other good place to introduce it in computer science curriculum other than an optional computer automata theory class. And honestly, you deserve to know it because it makes your life that much easier. That will be, regex is always one of those optional questions on the final exam. The way the final exam works is that I'll give you a selection of problems of which you'll need to choose a certain number of them. So if you feel more comfortable about turtles, you choose the turtle question. And if you don't, you skip that one. So if string count period, so if that string count is greater than or equal to 2. See, I got so hung up on regular expressions, I didn't even think about that. So if that's greater than or equal to 2, return false. And there you go. That's how you check that's kind of how, that should catch, I think, the vast majority of cases there for a floating point number to check if it's a valid floating point number or not. Okay? So running out of time here. So I will continue on with the 3-digit Armstrong numbers. Armstrong numbers are pretty interesting numbers. They are numbers that are that basically are self-referential in some way. So basically, it is a number where the 3-digit Armstrong numbers are numbers where the number is equal to the sum of the cube of each of its digits, which is a mouthful, but 370 and 371 are two examples of Armstrong numbers. Okay, 371, 3 cubed, 371 is equal to 3 cubed plus 7 cubed plus 1 cubed. Okay, so 371 is equal to this number. Okay, and for those of you, right, 3 cubed is equal to 27, 7 cubed is equal to 343, so 343 plus 27 is equal to 370, and then in the case of 371, 1 cubed, right, 1 cubed or even 1 to the billionth power is always going to be equal to 1, and 0 cubed is equal to 0, right, unlike 0 factorial, which is equal to 1. For reasons. Math is weird. Okay, anyway. So to check if a number is like this, we're going to use a lot of the strategies that we used over here. Def is Armstrong. I'm going to call it 3D Armstrong for 3-digit. We're going to take in a number, not a string. And again, I'm just going to go over this one quickly so that we can get to the more interesting problem. So, right, what we want to do is basically ask ourselves, again, true or false. Now, rather than, assuming 1, it's actually very easy to just do this. So what I'm going to do is I'm going to just simply say, okay, here's the hundreds place, here's the tens place, here's the hundred place, here's the tens place, here's the ones place, right? To get the hundreds place of a number, of a 3-digit number, I just take that number and divide by 100, right? Integer divide by 100 to get, right? To get the 3 out of 315, I would just divide by 100. For the ones place, we learned how to get the ones place of any number. You mod by 10. Okay, thank you, autocomplete. Okay, now to get the tens place, that's actually more complicated, but it's a 2-step process. First off, we take the number, we mod by 10, and we divide by 10 to throw out the rightmost digit. So now the tens place would be the ones place. Make sense? And now that the tens place is the ones place, we just get the ones place. Now, I'm not changing number over here because I'm not storing it in a variable, so that doesn't let me use it over here. And so now, to check if it's a 3D Armstrong number, I just have to check if the number is equal to the cube of the 3 of these numbers. So I ask if num equals, if num is equal to, and I'm going to go ahead and do hund, and I'll put it in parentheses because that makes me feel good. 100 cubed, the hundreds place cubed, plus the tens place cubed, plus the ones place cubed, right? Star to cube rather than caret to cube. Return true, else return false. Don't write this part down because I'm about to throw it out. Because this is actually the important part. Because the important part was not this part. The important parts were this part and this part, not the if statement over here. Now the reason is that when you've got something like this called an if, where you basically check if something is true, and if it is, return true, and if it's not, return false, you can actually very much simplify that. This is a Boolean statement. If it evaluates the true, you return true. If it evaluates the false, return false. So let's just skip that. return whatever the heck that evaluates to. Make sense? Because if it was true, because if this ended up being true, we return true. If it ended up being false, you return false. Just remember to delete the semicolon that we had at the end of that. I almost forgot to do that. Okay. Like I said, that was the less interesting one. That's why I kind of went over it so fastly. Watch the lecture recording if that math made you uncomfortable, because that was interesting, because it can be a lot to digest at once, but it isn't necessarily hard. So this one we won't be returning. This one we're just getting an answer. This is from Savage's Java textbook. I used to do this one as a homework problem, and I've simply copy-pasted it verbatim from Savage's book. Holy Digits Batman, the Riddler is planning his capers somewhere on Pennsylvania Avenue. And of course he left us a riddle. The address on Pennsylvania is a 4-digit number with the following properties. A 4-digit number where all 4 digits are different. The digit in the thousands place is 3 times the digits in the 10 place. The number is odd, and the sum of the digits is 27. Okay? Let's keep those rules next to us as we work. Okay? All 4 digits are, so what are the rules again? All 4 digits are different. Okay, here we go. Def Riddler. No inputs over here because we're just simply kind of cranking through a bunch of numbers. And we'll be printing that out. So first off, it's a 4-digit number, which means that the range is from 1,000 to 9999. So let's go, and then again, I'm going to go quickly here because we have only 6 minutes left. So, to go through, so that means that we'll write a for loop that checks over that range. For num in range 1,000 to 9999. Well, actually 10,000 because we want to go up to but don't include the 9999. Sorry, we want to go up to but don't include the 10,000. Got to get all 4-digit numbers. Now, we look at these things, all 4 digits must be different. The digits in the thousands place is 3 times that of the ones place. Or is it the tens place? 3 times that of the tens place. We'll come back to that one later. The digit is odd. Okay, that one we can kind of enforce without any if-else checks by just simply manipulating the range of numbers we're going over. If instead we start at 1001 and go up by 2s, then we're just going to be checking all only odd numbers, right? You could write an if-else statement, but honestly, I love in Python that this makes it easier to do. So there, right? That makes sense to everybody? So there we go. That's one condition already done. Now, these all reference doing individual manipulations of the digits. So now what we have to do is actually the actual hardest part of this, which is extracting each of the digits. So I'm not going to copy paste because it gets slightly different here. The thousands, the hundreds, the tens, and the ones place. The reason I'm doing this, I'm just spelling them like that, is that so they're all 4 letters long. That makes it a lot easier to kind of type and distinguish between each other. Okay, the thousands place. To get the thousands place of so the thousands place and the ones place are the trivial one here. Thousands place of this number, we divide by 1,000, right? If it's 4,000 something, to get the 4 out of the 4,000, to get the 4,000 out of there, to get the value in the fours place, we would divide by 1,000, right? 4,000 divided by 1,000 gives you 4. The hundreds place and the tens place are a bit difficult. We'll skip those for a second. Just to remind us, how do we get the ones place? We get the ones place the way we always do, by modding by 10 to get the last digit. Now, to get the tens place, that works the same way as we did in 3D Armstrong number, which is that if we throw out the last digit, then the last digit is then the tens place becomes the ones place, right? If I throw out the last digit, right? So if I take so if I take 4,321 and divide by 10, I'd get 432. If I take 4321 and divide by 10, I get 432. And then I just simply get the last digit of that new number. And so we just simply repeat over here for the hundreds place. What we do for the hundreds place is that we divide by 100, right? To chop off not one but two digits, right? 4321 divided by 100 very quickly would give you 43 point something, except we're doing integer arithmetic, so it just gives us 43. Then mod by 10 to get that last part. Great. Like I said, that was the hardest part of this one, because again, modular arithmetic is not something you really do outside of computer science too much, even though you do it all the time when you're talking about clocks. That's modular arithmetic. Okay. So the digit in the thousands place is, so if the digit in the thousands place is 3 times that in the tens place. So 1,000 equals 3 times the tens. Okay. Then we have one more condition. Actually, I'll do that as an inner condition, because now we have, so we have all 4 digits are different. If the sum of the digits is 27, if thou plus hund plus tens plus ones is equal to 27, we'll go ahead and print out the number. And give me 1 second over here to just let me go ahead and dedent this. Format, control. Okay, there we go. And then let me go ahead and do Riddler. And we still have one more condition to do over this, which is the most tedious of them. But so now we've got 2 different kind of things, which is to check if they're all different. Okay? Now check if they're all different, what do? We make a big conc and if statement. That's what we do. We say if thou is not equal to hund, and there's a better way to do this, but not one that you know, and thou is not equal to tens, and thou not equal to ones, and hund not equal to tens. We don't have to check thousands again. And hund not equal to ones, and tens not equal to ones. We only had to check if A was equal to B. If we check A is equal to B, that's going to do the same as B is equal to A. And there we go. We get our answer. All right, so that's it for today. I went slightly over time. Sorry about that. So I'm going to stop recording and upload this in the previous lecture.